EOS blockchain accounts, how they work. Not all blockchains and crypto addresses work in the same way, and therefore we must understand and study their functioning in detail from time to time, and in this case we will see how an account on the EOS blockchain works in detail. What are RAM, CPU, and net? An account on the EOS blockchain is based on three fundamental elements to function, namely RAM, CPU, and net, and they are all complementary to each other, and where based on what we do, more or less resources will be required from our account. All these network resources are provided by block producers, which we can compare to the miners of the Bitcoin blockchain. Furthermore, the quality of the hardware they use is also fundamental for users, so they can know what type of hardware relevant block producers has and therefore decide in case of voting for it. This also means that block producers allow dApps and users to use their own hardware to save and process transactions, thus allowing users to access different BP servers and solving the centrality problem of everything. The RAM on EOS. In the computer context, RAM, random access memory, is a form of data storage where the instructions that are being used at that moment are saved, and for this reason its task is to maintain those instructions for a short time and allow speed of reading and writing quite quickly. While the RAM in EOS is completely different because it does not correspond exactly to that concept. In fact, the RAM is as if it were a kind of virtual memory of the account to save information permanently, such as the account keys or the relative balance, but also NFTs and data. RAM is very important for dApp developers. In fact, all the operations needed for the dApp are saved in RAM, and if this is not sufficient, then some operations cannot be carried out and the related smart contract cannot be executed. In fact, RAM is used precisely to save the smart contract within the account, and thanks to this specialty it is also possible to update the smart contract without problems, without recreating the smart contract from scratch on a new account. Since RAM must be purchased separately, then this follows a market and trend that is detached from the trend of the EOS token, because when you free RAM it does not mean that you have the same amount in EOS that you used to buy it, and therefore this is what is called RAM trading, where there is no peer-to-peer exchange and transfer, but the counterparty of all participants is the system market maker, in this case a smart contract. The current system uses the banker algorithm, where it does not set the price of the RAM but offers the buyer and seller a previous rate that was established in the market, and therefore the rate will be different from what the algorithm, and therefore the traders will offer. They will try to make their trades at a price close to the market price, where the advantage is that the market sets the price, and this system simply responds to what the market offers. Furthermore, when you create a new account, a minimum amount of RAM is required for everything, and therefore you have to buy it if you don't have it beforehand. With around 4,000 bytes it is enough to create an account, and this is why you have to pay to have a new account on the EOS blockchain, because we are actually taking up space. The CPU on EOS. Every time a transaction is sent over the EOS network, block producers must process that transaction, and CPU is the length of time, measured in microseconds, that a block producer must spend processing and validating the transaction. Since each block producer uses a different infrastructure, the CPU is different for each block producer, and therefore this has led to the development of tools to measure, as precisely as possible, the relative execution speed for each block producers. In the EOS ecosystem, blocks are created every 500 milliseconds, and to help block producers have enough time to push these blocks out into the world, there is a block processing time of 200 milliseconds within which the block producer must validate the block first to transmit it over the network, and therefore this allows you to have 300 milliseconds to propagate everything over the network. In the past on this blockchain it was enough to stake EOS to obtain power to make transactions. Now this system has been weakened as too many unused resources were blocked. Now the CPU power can be purchased only when needed, with very low and above all predictable costs. With 1 EOS we will be able to make thousands of transactions, which makes it very convenient to operate on this transaction. Furthermore, some wallets such as Anchor provide around 10 transactions free to everyone. and therefore in fact we will not even pay those 0.0002 EOS cost for the transaction. The net on EOS. As regards the network, like RAM, it is measured in bytes, but this is another resource available to the account and represents the throughput capacity on the EOS blockchain. Therefore, it is the total data that can be sent from one point to another in a specific amount of time. We can compare it to the data traffic available on our SIMs, where once the threshold is exceeded we have to pay, but usually not much power is required for the net, and an action consumes on average around 150 bytes. Conclusions. At first it might seem chaotic and difficult, but in everyday use it is quite simple to use the account on the EOS blockchain, as our wallet will show the cost of the transaction when necessary, and the same will be deducted from our EOS balance that we will have liquid in our account. Considering the speed and cost-effectiveness of the EOS blockchain, all those operations that require multiple transactions, such as high-frequency trading or in the gaming sector with Web3 video games that require fast and economical transactions, can be performed efficiently and without slowdowns. In fact, let's not forget that on this blockchain, due to the dynamic scene, it is almost impossible to congest it and therefore slow it down.